Mobile devices are used all over the world, and so it's important from the corporate side to make sure that we have a way to centrally control the configuration of mobile devices, because they're being used for business purposes. It's just another computing device. And that's important to know because really, why shouldn't it have a host-based firewall app installed on it? Why shouldn't it have a virus scanner installed on it? It should. It's just another computer, just fits in your pocket. So there are a couple of ways that organizations will provision mobile devices to be used in the enterprise. One of those is bring your own device, BYOD. This means what it sounds like. It allows users to bring their own personally owned smartphone to be used in a corporate environment. Now, what that means is often that the IT department will have to have some kind of centralized policy applied to the device to harden it in alignment with organizational security standards. Another variation of mobile device provisioning in the enterprise is where the organization has a collection of devices they support that employees can choose from. That's called Choose Your Own Device, or CYOD. Then, of course, we have corporate-owned, personally enabled, otherwise called COPE. This means that it's a phone issued by the organization to be used for business, but it can also be used for personal use. Now, the other thing to think about is if we've got a phone that's being used for dual purposes, for personal and for work, what are the security implications? They are large because everyone is using phones, everyone's connecting to apps, websites, and so on. So what we have to think about is partitioning the device. Creating a device partition doesn't mean a hard disk partition, but what it means rather is that we have a logical division or boundary between personal data, apps, and settings, and corporate data, apps, and settings on the same device. If we can have that kind of a logical boundary, it serves centralized management of these devices well, because if the device is lost or stolen, and there might be some sensitive data on the phone, not even sensitive data, maybe there's a VPN app on the phone that would allow access to a network elsewhere that would indirectly allow access to data. Same kind of problem, but we have a way that we can wipe that corporate partition only on that device, as opposed to wiping the entire phone if it's lost or stolen. So as long as phones are registered with a central management tool, they can be remotely wiped, either the whole thing or just one of the partitions like the corporate partition. Any device that can communicate with a cellular carrier network, whether it's a tablet or a smartphone, has a SIM card. SIM stands for Subscriber Identity Module. Here we have a picture of a SIM card, very tiny, and it plugs into the device physically. Now you need a SIM card to authenticate your phone to the carrier network. It contains enough information to know that you're allowed to transmit and make phone calls and you have a data plan on that network, whether it's Rogers or Telus or Bell or whoever it is. So the SIM card contains that type of account information to allow you to get on the network. It contains a serial number. It also, in some cases, will contain phone contact information, as in contacts that you might have added to an address book. Now there's a notion related to that called carrier unlock. So we know that the SIM card gives you access to a cellular network. But carrier unlock is a feature that is available with some carriers where it will allow you to keep using an existing device that you might have had a SIM card that allowed you to connect to a different carrier. Now you're switching your provider. So you can reuse that same device by using the carrier unlock feature. Now, in order for that to be available, it has to be supported by your carrier and your device. So you would need to check the requirements from your carrier to see if that's even an option. Now that's all wonderful, but what can we do to harden our mobile devices? Well, reducing the attack surface, that's a general umbrella term that we've heard a few times. We need to make sure that we disable unnecessary components on the smartphone. If you don't need GPS tracking, turn it off. Not only might that enhance security because your device can't be tracked, but it also saves on battery power. Just like disabling NFC or Bluetooth or Wi-Fi when you don't need it saves battery power and potentially could reduce the attack surface. The less visibility you have on a network with your devices, the more secure you will be. It's just the way it is. Now, how do we manage these on a large scale though? I can go to an individual smartphone and I can go to all my settings and I can harden this one individual phone. But imagine a large enterprise that has thousands of employees, each having a phone. You're not going to go to each and every phone and harden them. So we need a centralized way to do that. That's called a mobile device management, or MDM solution. This is software, either that you run on premises. These days, most of that is actually run in the cloud, where devices register with this centralized MDM tool. Once they register with it, policies can be configured and applied to the devices, and those policies would harden the phone, like turn off the camera. Our employees, for instance, do not need the camera enabled. We disable Bluetooth because we don't need that the way we're using smartphones for our business, and that can be enforced and set so that users can't even change it back. So we can also prevent things like side loading. Side loading is a notion that relates to mobile devices whereby instead of installing apps from an app store, if you have the actual installation files for an app, whether it's Android-based, Apple iOS, or Windows Phone, if you have those actual files for the app, sideloading means you're installing it without going through an app store. Naturally, we probably don't want to allow that to happen because, for instance, if we have a stolen smartphone, a malicious user that stole that phone might be able to sideload an app that would give them full access to the phone. And if there's a VPN app that allows access to a corporate network and someone decided to say, remember my name and password, which you should never do, you can see where this would spell trouble. So we want to be aware of that. Now, the other thing to think about with mobile application management, that's managing the apps on a phone, is also geofencing. Maybe certain apps can only be used when a user is in a certain physical location. So you can only use app A if you're in an office building environment. The other thing is also using security enhanced Android, for instance. This is called SE Android. It's kind of like security enhanced Linux, SE Linux, except it's for an Android phone. Well, what does it do? For really stringent environments that have high security requirements, so maybe law enforcement use of mobile devices or military use, we can enable SE Android, which is very limiting in what you can do on a phone. It uses labeling, it's mandatory access control, labeling for file system resources, network ports, and you have to have certain security clearance on that device to be able to access those resources. So that wouldn't be something you would see often, but it is used in high security environments. Now, another thing to think about is when you have a centralized mobile device management solution, it also allows for unified endpoint management. That means that we can even deploy firewall configuration settings on smartphones. Yes, your smartphone should have a firewall. Of course, it's just another computer, remember? Also, we can centrally deploy virus updates. We can centrally install apps. Of course, we have a central way to remotely wipe, as we've discussed as well, if the device is lost or stolen. We already know that part of hardening or reducing the attack surface includes strong authentication mechanisms. So using a complex password if that's how you're signing into your phone, or using a hard-to-guess PIN, or enabling facial recognition or fingerprint scanning, that type of thing. Another consideration is enabling encryption for your entire device, your entire smartphone, potentially even for any micro SD cards for additional storage that you might have plugged into the phone. We all know that if data is protected at rest, if it's encrypted, even if someone gains physical access, in this case to the smartphone or the micro SD card, they're not going to be able to get into it unless they have a lot of computing power and a lot of time to try to crack the decryption passphrase. So, cryptographic operations. Let's think about this for a second. In a smartphone, we have an option of using an SD card, of course, for storage. I want more storage than is available and built into the phone. But we also have a micro SD hardware security module, HSM. What is that? Well, that's a little SD card that you can plug into a phone for high security environments, where that SD card is used to store cryptographic secrets, and also it performs cryptographic operations like encrypting, decrypting, digitally signing things, verifying digital signatures, generating hashes, thereby offloading it from being a requirement built into the phone. Pictured on the screen, we have a couple of examples of what you might do to harden an Android smartphone. So by going into the settings on your phone, depending on the version of the OS running on the phone, will determine exactly what you see. So maybe enabling facial recognition, maybe adding a fingerprint scan if that's how you want to authenticate. Maybe making sure that we enable the Find My Phone, or in this case on Android, Find My Mobile option. If your phone is lost, or you forgot it somewhere, or it was stolen, you can track it online, track its location. Now, as long as you have strong authentication on your phone, if someone stole your phone, they won't be able to go into it to turn that off. Of course, they could always try to turn off the phone itself or remove the battery from it. Also, making sure that we don't allow the installation of unknown apps. You can even prevent the installation of apps from known app stores like Google Play or the Apple App Store if required by organizational security policies. And finally, we see other options like encrypting or decrypting an SD card that was inserted in the smartphone. So because smartphones are so ubiquitous these days, it's important to have a centralized way to manage multiple devices in the enterprise.